Hello, Integrated Math 3 students. We're going to start our next topic for this unit. We're talking about graphing functions. You've definitely graphed functions up to this point in your other math classes. So we're going to review that. We're going to be looking at more of the advanced type of polynomial for graphing. We got 3 different tools we're going to be using to help us graph. It's up to you what you want to use. We have the different calculator options, and then of course Desmos is something that we're going to use as well. Okay, so let's go ahead and talk about what you need to do for how would you graph a function. So we're going to say graph in your notes. Make sure you got your notebooks out. You can title it, either start a new page, draw a line from where you left off last time. Probably start a new page would probably be better. But the title's up here, graphing function and identifying key features. But let's just start with graphing a function. Here's my general rules for it, and I'll break it down into steps. First, you want to make a table of values. Your X and Y tables. Okay. That is what's going to generate your coordinates, your X and Y's. And we want enough of those, so that's part 2. You want to plot enough points to get a good picture. So just plotting 2 points, 3 points, even 4 points is most of the time not enough. You can't really tell what's happening with the graph if you're not plotting enough points. Okay, so you want to make sure that you plot plenty of points. So we're going to do an example here in a second. Number 3, third part, is to identify key features. Okay, identify key features. And what that includes, and you should define these in your definitions assignment. You have x-intercepts, you should have y-intercepts, and then last thing that we want to consider looking at is what's called extrema. So and extrema. Again, this is something that needs to be defined in your definitions. Okay. Also, this video is going to be broken up into, or this section of this unit is going to be broken up into 2 videos. We'll be talking about extrema here in a bit, but let's go ahead and look at an example. And in your homework assignments for Delta Math, that's where I'm going to be pulling these examples from. But let's consider graphing this function f of x equals x to the 4th minus 4x minus, or excuse me, 4x to the 3rd minus 49x squared plus 136x plus 420. All right, so that is a very complex looking function there. So write that down. And we're going to follow these steps. So the first thing is we're going to make a table of values. So there's 3 ways you're going to do this, and I'm going to show all of those for you. So the first way, I'm going to talk about this. This is coming from your Delta Math assignment. Look on here. This is where I'm grabbing this from. So I'll sort of work through this example with you guys while I'm doing this. So let's start with the TI-84. This is the classic calculator for graphing. So let's start with, how would I create a table of values for this? What you do on your 80 series calculator, you hit y equals up here, If I just go to the home button, this is the home screen, hit y equals, and I start typing it in. So I'm using this for my X button. Raise it to the, I use this little caret symbol they call it, raise it to the fourth. Down minus 4x to the third minus 49 squared. By the way, if you have a Chromebook, you can actually get this software for free. So let me know if you're interested in that, and I can send you a link to download this for free. They're giving that away for code, so, or for the distance learning and all that. So here's our function. If we graph it, we can't really tell much at all. Like, it's just a bunch of lines, which is why we don't use the graph. We want to use the table. The picture is deceiving. The reason is because the window that we have, it only goes from -10 to 10 for all our x and y axes. So we trust the table. Here's our table of values, and this is what you want to have. And you can see some of these are pretty large numbers. And if we look on our axis over here, zoom in, we have from -10 to 10 on the x-axis, and then from -1,000 to +1,000 on the y. So we know that our y values here, that should make sense. Let's talk about the Inspire. So TI Inspire, if you have that, let me reduce this a little bit here. So if you're using the Inspire, all you need to do is click Add Graphs Document, and here it is. So now you can start typing it in, x to the fourth, or minus 4 to the third, minus, you got to see on this one, you got to make sure you come down, minus 29x squared plus 136x plus 420. Okay, hit enter, and you'll notice that it looks pretty much identical to the actual graph of the 80 series calculator. Now again, if you don't have either of these calculators, you're going to be able to use Desmos for this, so don't really sweat it. But I'm just showing you how you can get to the tables. The tables actually show up a little bit better on these than they do on Desmos. But to get to your table on here, all you have to do is hit Control T, and boom, there it is. Table pops up. You can scroll through and find the values you need. Okay. All right. Last way you do this is through Desmos. So I'm going to pull that up to the side over here. That's over there. Okay. So in Desmos, all you have to do is go to desmos.com. Show you how that pulls up. Desmos.com. It'll take you to this. Hit graphing calculator. Boom, you're there. And it's actually pretty easy to type on this. It's actually easier than a calculator. So if you hit X and this A to the B button, you put the 4 there, and then you don't have to go down. It actually just knows that you're going to type down low. And you can see it changes live as you're doing it, which is really nice. You can see sort of how adding all these terms to this changes up the function itself. So now I need 136 x and then plus 420. So again, it still is looking like what we saw on the other applications here. Okay, so but on Desmos, it's very easy to go ahead and zoom out. The problem is that, you know, it's hard to see. You can do this on your phone, as a matter of fact. You don't even need the computer. And what you can do is, if you put your fingers on the x-axis, watch this. I'll flatten it out. Just keep doing that, and I get a really good idea of what it looks like. And if I want to with the x-axis or with the y-axis, put my fingers on it and pinch it, it'll flatten out that axis as well. So now you can get a really good image of flattening and skewing it. Okay. So this is what it should look like when we're done. So I know something like that needs to be over here. But again, I'm not here to just guess what goes on the graph. The first step was I need a table of values. So let's talk about a table of values in Desmos. See this little gear here? If you hit the gear after you've typed in the function, you can insert a table. So let's go ahead and do that. Convert to table. All right. So what's tricky about this, and you'll notice it's already plotted all these points here for us. can't even click that one, but you can click them and they pop up pretty easily. But what's a little bit tricky about this is that you have to input the values. Let's zoom fit there. You have to enter them in one at a time. So this is kind of weird. Watch how I do this. If I click up here and hit enter, it gives me a spot to type in a number. So I want -3 there. Obviously go back up, hit enter, -4, enter, -5, so on and so forth. And I want to get my full X values in. So I'm gonna go from -10 to +10 to make sure I've got the best picture possible for my graph. -9 and -10. Okay, now that's the tricky part with Desmos. Obviously in our calculators, when we went to our table, just easily scroll up and down and find all these things. So that's nice. And on the Inspire, yeah, I can just click through and scroll through and I'll find it. Desmos down, this is actually pretty easy. So right here, if I just hit enter, it's gonna start doing the other direction. Watch how on the graph itself right here, it's starting to add the points, right? And now I'm at 10. So you'll notice what the problem is with these numbers. So check some of them out here. My y-axis only goes to 1000. So any number above that or below the -1000 or above +1000 is, I can't fit on there. So I'm really only gonna plot the values from starting at -7 all the way to, looks like 8. And yes, you need to plot all of those for this to work. So let's go ahead and start. -7, 840. So you're gonna give your best estimate. So I'm gonna go over here. Please zoom in on this now. Move that over so you can get a really good view since I got my values there. So -7 up to, I'm looking for close to 840. So a little bit of past 800. So right there is good. -60. Wow, it shoots way down here. It's -60. -5, 360, -360, so about right here. -5, -4, -396, so almost 400 right there. Good. Let's do the next one. -3 to -240. Go -20. Good. -1, 240. +240, so about right here. And all this is approximation. You won't get the answer wrong if you do it like this, so don't worry about that, but just get it pretty close. 0, 420 is the y-intercept. 1, 504, so about right here. 2, 480. Boom. 3, 360. And then 4, 180, 50, 6, -96, there, good, 70, and then 8, 420. So on the 8, 420, put it about where that other one is. There's not really any others I can do. But look how great of a picture we have of this graph, and you'll notice how it almost looks exactly like the one on Desmos. And if we were to change our axes on the 84, when we go to our graph, like if we changed our window for these, we could get it to look the way it does. For instance, let me do that on here. So let me do window, do the Y minimum as -1000 and then 1000, and then watch what happens when I graph it. It should look almost like it. Yeah, that's a better picture. So it's all about having your windows set correctly. So let's plot it, and there it is. It fills in. If you don't do it correctly, look how off some of mine were. Look at these dots. You know, it's gonna know that you got really close. There's only so much humans can do when they're doing this. All right, so that's how we want to graph. Let me go back to our notes here. That's how we want to graph a function. Okay. Now, we want to identify the key features. First off, what are the x-intercepts? So let me pull up our graph. So let's write that out, x-intercepts. And your definition for x-intercepts are where the graph crosses the x-axis. So let's pull up Desmos and we're going to look at that. Desmos is right here. All right, x-intercept. So there's one here, there's one here, here, and here. So So we need to list out every single one of those. So the x-intercepts are, I need to be able to see this in the same time. -6, 0, -6, -2, 5, and 7. So I'm going to write those as ordered pairs: -6, -2, 5, and 7. Barely fit in there. Okay. Now, what about the y-intercepts? Y-intercepts where it crosses the y-axis. It's only ever going to do that one time for it being a function. So let's look at the graph. Where does it cross the y-axis? Well, that's when the x value is 0. So that's a definition for you. It's when the graph crosses the y-axis or the x value is 0 at 0, 4, 20. Okay. So the last thing that we're going to talk about are the extrema. Known as your maximums and minimums, relative maximum and minimums, and we're gonna talk about these a little bit more later in this lesson. But you'll notice how this winds. It goes down, then up, then down, then back up. Right? It's sort of like a roller coaster. So on this graph, you have a minimum somewhere in here, and we call that a relative minimum, and it pops up right there for us. That's what we would call a relative minimum right there. So I would write that down. I'm going to move this over for a second. I would write that down as this. An extrema would be, we're going to say a minimum, going to be -4.3, and I'll round that up, 38. And then the y value is -411. We'll say 57. Okay. Now there's also another minimum on this graph. Let's move around. Let me zoom out a little bit. We have another one over here. Let's go check that out, and you'll see that it pops up right there. And it's Desmos is really good about finding these. The Inspire and the let's just go to this one because we have it graphed. It's really kind of a pain to actually find those on these calculators, but it's something that I'll show later on. Okay, but for now we'll just use Desmos. So the other one is we'll just call that 6.1, and that's we'll just call that -97. So is that it's 6.1 comma, that was -97. I'll put -97.03. Okay. Now we also have a maximum in here. So it's very important that we identify all these things. Maximum is going to show up here at where it pump is, and here's the numbers we get: 1.273, and that's the x value. The y value is 508.096. Slide that over. I'll keep it handy. So we get 1 point. I'm going to round that to 27, and then 508.096. I'll just have that whole thing in there. There you go. All right. So there are our key characteristics of the graph. Okay, and that's how we want to be graphing these. All right, we want to give a very detailed graph like this. Let's say I had you do it on paper. You'd want to include a lot of these points. You can use your calculator to give you a good image of it, but we want to be able to graph this properly. Okay, now just because I'm already in here, we're going to talk about the next part of this, which is we want to take this graph and write it in factored form. So when we did our review for iMath 2, we did factoring, right? So we know factored form is when they're in those parentheses and binomials. Okay, so we're going to write down some steps. So this is what I'm going to have you do in your notes. Let's draw a line here. Straight across, section it off. Okay, and and in your notes you can do that with a pencil. Let's talk about next topic: putting a function in factored form from a graph. Now you could do this with quadratics too. It's not just these quartics, which is, by the way, that's the type of function we're dealing with. The last lesson we had, we talked about identifying. This is a quartic polynomial. Highest power is 4. So we don't really have factoring techniques for that. There is no slide and divide or anything like that that you can use to factor it. We've got to use the graph to actually help us with this. So we're going to use the exact same example, but here's the steps for this. We're gonna start with step 1. So in your notes, write this. Step 1 is going to be identify all x-intercepts. Okay, good. We've done that with our last example, and that we had those as this. So I'm going to actually write these down here. So we had x equals, I think I remember what they were. I'm just going to look up there just to be sure. -6, -2, 5, and 7. Okay, so -6, -2, 5, and 7. Okay. Those are our x-intercepts. Step 2, we're going to write them as binomials. Next part is very important. You want to use opposite signs. Something we can elaborate on further down the road. We kind of already know why from our review and from iMath 2 why we need to use opposite signs, but this is what that would look like. So we have the -6, x equals -6. That's going to change into x plus 6. We have the -2, it's going to be x plus 2. We have the 5, it's going to be x minus 5. We have the 7, so it's going to be x minus 7. Good. So we've written those out, and one of the steps I have in here is to write those the binomials side by side. Which we've already done. And then our fourth step to complete this, we're going to write them as a function. We're going to say write as a function. Use the same lead coefficient from polynomial in standard form. So if we go back up here, we had our polynomial in standard form. Our lead coefficient, here's our lead term, was 1. So what I mean by that is when I'm writing this up in function notation, so this is f of x equals the very first term. I've got all these binomials, x plus 6, x plus 2, x minus 5, and x minus 7. I need to make sure I have the same lead coefficient right in front of there, which is 1. So I don't really need to even write it, but I will. But I put the 1 up there, and I know that this is the correct function for this. So this was the problem for Delta Math. So let's go and see if I got the answer correct. So I need to type in, let's do this, it'll be x. We started with plus 6, x plus 6, x plus 2, x minus 5, and x minus 7. See if we got it right. We got it. Okay, very good. So again, it's factors have opposite signs of the x-intercept. So that's that rule that we talked about here for use opposite signs. And if you would, go ahead and underline that. That's mega important right there for you to remember. Okay, use the opposite signs. Good. All right, we made good progress here. Let's go ahead and continue with the next part. All of that is going to be practiced in your Delta Math assignment, by the way, so make sure that you get some practice with doing that. And you saw my example here. So let's go ahead and go to the next topic, which is going to be maximums and minimums. Draw another line, you do the same. We're going to talk about finding maximums and minimums. So in your definitions, you had to define what's called extrema. So you can write that in your definitions. You don't have to write it here in your notes, but extrema are all of. So if a problem says what are the extrema of the function, we already defined that. They are the maximums and minimums. So extrema are the maximums and minimums of a polynomial. So we can find extrema using technology. We're going to use, I'm going to keep it simple for this. We're not going to put in like a crazy polynomial like we saw for the last example. We're going to be using some quadratics to do this. The extrema of a quadratic is known as a vertex, which we practiced finding that in the review. So let's do some examples for this. Example, first off, and I'm going to pull up Delta Math again. Over here, I'm going to go to finding maximum minimum. So we're going to use this. Here's our example. Going to be, so this is example 1. We have x squared plus 8x plus 22. So it wants the minimum value of that function. So let's show this with the 80 series. So I'm going to clear this. So let's type it in: x squared plus 8x plus 22. If I graph it, you can see right now that it's not very clear. If we hit zoom and then standard number 6, it should fill in our standard array. Okay, so there we have our graph. So let's talk about how you will find the minimum. You do the same thing for the maximum on here, and then we'll do the same exact problem on the Inspire, and then we'll do it again on Desmos. So all I need to do to find the minimum here is I'm going to press second trace, and it takes here, and you'll see there it is, minimum. And I hit enter. All right, so first thing it wants you to do is find the left bound. So if I use the movement keys here until I can see it, you'll see the x value, and we know that our x value is over here negative. So I want to get the left bound. I know that it's probably about right there, but I want to go to the left of it, hit enter, go to the right of it, and you can see those boundaries there. So now I'm to the right, hit enter, and look at that, you have the boundaries. And then it wants you to guess where you think it is. So I'm going to go, I guess that it's about right there. That seems right. So I'm going to hit enter. Okay, so it gives me that value. But what I really want is the y value because it wants to know the minimum value of the function. Okay? Well, for that, I'm going to type in a 6. Submit answer. And I got it correct. Okay? And that's how you would do that. Let's look at it on the Inspire. Let me start a new graph here. Okay, so I got a new graph. I want x squared plus 8x plus 22. And there it is. So how do I get that? Well, I press menu, analyze graph. Here it is, minimum. And so you'll notice this pad right here is a touchpad. So you can brush your finger on that and it will move it to the left, like over here, or to the right. So we want the lower bound. So I'm going to go to the left, then I'm going to go to the right, and there it is. That's my minimum. I want the y value. Again, that's that 6. Last one, last way to do it, and again, my favorite way to do it. You're at Desmos. Okay, here you are. All right, so let's look at Desmos. I'm going to hide this graph. I'm going to delete it actually. Okay, here we go. So x squared plus 8x plus 22. And Desmos is so nice because you can move around so much easier than those calculators. So all I got to do, click, done. Much easier, much faster. And we want the y value. Let's try that again with this question here. This one has decimals. So negative 1.4 x squared. Again, you can do this on your phone. Minus 5.7x minus 2.4. Okay, and this one wants the maximum value. So I'm going to go here, click, done. Round it to the nearest hundredth. That means to 2 decimal places. So I'm looking right here, 3.402. Well, I would round that to 3.4 because the 2 doesn't round up. So 3.4. Submit. Got it. Okay, there it is. And that is finding your minimums and maximums using the technology. That's how you will need to do that. You're not going to be doing any of that by hand. Okay. Finding those extrema. Let's move along. Things we're going to talk about in this part of this lesson. Remember, this is quite a lot lengthy lesson, but we're doing great. 2 more parts here. So put another line in your notes. All right, let's talk about increasing and decreasing domains. All right, so I'm going to pull up an example on the screen here for us to look at. I'm going to pull this little image here. All right, so let's put that one away for a minute. Okay, so I want you to look at this, and you'll notice how a lot of these polynomials we've been looking at are windy, right? They wind quite a bit up and down. So sort of the helpful tip for being successful at deciding on increasing or decreasing domains is thinking about it like you're riding a roller coaster, and you start on the left side over here and you go woo all the way down and then shoot back up. And you know how it goes clink, 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 clink up to the top, and then you whoosh down, right? Okay. And some polynomials you're going up and down and up and down and up and down, right? So those have a lot of intervals of increasing and decreasing. So that's what we're going to talk about here. And I'm going to write this. So to find these, I'm going to say imagine writing the polynomial like a roller coaster. So starting from the left, we're going to write the interval of x values. I'm going to capitalize this. And you should too. And then you should put a box around it. Underline it. Okay? We're writing the interval of x values. In your notes, I said something about interval notation. That's going to come into play here. So interval notation, you need to make sure you have that defined and understand how that's written. Okay? So we're writing the x values where it increases and lagging a little bit here. Say separately. Decreases. That's what you got to think about. If I pull up this graph again here. All right, we're starting on the roller coaster. What am I doing? Decreasing. Okay, how long are we decreasing? Where does it start decreasing? Where does this ride actually begin? Well, don't say -5, right? Think about these graphs as infinite entities. This thing keeps going on forever. So the starting point is -infinity over there, right? Let me actually want to write on this. I'm going to put this. Actually, I don't think I can. That's okay. It starts way over here, but it goes and it stops about -2.5, right? Then it goes up. So now the roller coaster is increasing. So what is that? From -2.5 to positive, it's about 2.75. It's increasing. Then from there to infinity, it's decreasing always. So that's the idea here. Now let's look at this question. It's saying choose the answer that applies. All right. We want to select all the intervals where it's decreasing. Well, look at how it has this. So in this notation, between -5 and -4, is that true? Yes, definitely. Between -2 and 2, so -2 and 2, it's increasing, so no. How about 3 to 4? So from x value 3 to 4, yes, it's decreasing. Let's check our work. We got it. Let's try another one. This is very interesting. What do we want to find here? Find where it's increasing. So let's see, -4 to -3. So -4 to 3, it looks like it's going up, right? Between those two x values. Look at -2.5 to -2. Is it increasing? Looks like it. How about 0.5 to 1.5? So positive 0.5 to 1.5. It looks like it's increasing. Is that what we want? Yes. So it looks like all these work. And we got it. Okay, so that's the idea for increasing. On Delta Math, you have all these quadratics. All right, so it's saying determine the domain where the following function is decreasing. So you can write it in that notation you just saw, or we'll be using interval notation. So let me try this one with you. So decreasing. Well, it's decreasing from here. What's the x value? Well, the x value is. So I'm going to write it like this, and we have to write it in parentheses here. So from 7, when does it stop? Well, this one actually does stop. Look how it has the solid point. It doesn't go on forever. I would normally put infinity if it kept going. But in this case, it stops at 15. So 15. So I submit that. Good. And there it is. It's decreasing. You're riding it like a roller coaster, okay? Okay, next, let's talk about new topic here. Moving right along. Talk about positive or negative domains. So let's have the same exact mindset. Let's imagine we're on a roller coaster and we're going up and down and up and down. So We're going to say that imagine riding a roller coaster, or riding the polynomial like a roller coaster. So start from the left. And write the interval. Of x values. Again, box that, underline it. It has to be x values. You don't want to consider the y values here. Where you are we'll say above ground. Okay, so above ground, and I'm going to put in parentheses what we mean mathematically by that, which is positive, or f of x is greater than 0, or sort of three things to keep in mind here with this. So positive, greater than 0, or above the x-axis is really what we're trying to get for. Okay. Or below ground. Imagine the roller coaster goes into the earth. Those definitely exist. Which, when it's below ground, you would be considered negative. Or the function is f of x is less than 0, or below the x-axis. So there's practice for you in Delta Math. We're going to look again at this Khan Academy practice site here. Let me scroll up. Look at some of the other topics. So we want positive intervals, negative intervals. So looking at this, select the interval where f is positive. So imagine it's a roller coaster. Whoosh, 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 whoosh. When are you above ground? Because that's what we want. We want positive. So when are you above ground? Well, -4 to -2. So -4 to -2. You're below ground, so that's not it. -1 to 1, above ground. That works. There's just one answer apparently. 2 to 4, you're below ground. So let's check that. Piece of cake. Let's do another one. So we want to know, where is it less than 0? Okay, so that means negative. That means below the ground. So -3 to -2, no. 2 to 3, that's not it either. 4 to 5, yes, it is below. So that's the idea. You also have some problems on Delta Math for this, so let's look at Delta Math, positive negative domains. Again, with a quadratic, when is it positive? So above 0, you can put the interval. So when is it above there? Well, from 3 to 7. So we'll put that. And this time we're going to use, we're using parentheses again. So we're going to say from 3 to 7. Got it. And you can see that's where it's positive. We represent that with a green. Let's try a new one. When is it negative? Well, between -1 and 3. So -1 and 3. There it is. And they're going to show it as negative. So that's a red. Okay. So that's going to be part 1 of this characteristics of polynomials. If you have questions, please feel free to email me or send me a reminder. I will get back to you promptly.